So again, my name is Jonathan Walters. I am a software developer. I have been doing it for a few years now. I actually worked with Eric kind of at my first job, and I was working kind of in React and React Native. Sorry, not my first job, but my first job working with a team, developing software. We're at a company called Scandy, and that was a lot of fun. Got to learn a lot from Eric with regard to. One second. Anyhow, got to learn a lot about functional programming. Today, I'll be talking about functional programming. It's, I think, kind of what has largely kept me going in always wanting to learn more. Good. Okay. I think it's just because I hadn't. There we are. All right. Sorry about that, folks. Anyhow, so I'm a big fan of functional programming. I'm always trying to research, always trying to kind of learn more. Today, in particular, I would like to talk about sort of my, love of functional programming as it pertains to JavaScript specifically. Now, we don't often think about JavaScript as the most functional of languages, especially since it has such a kind of imperative background. However, I feel like the kind of programming in the functional paradigm for JavaScript has been gaining a lot of traction in more recent years. I would say especially with the advent of functional libraries such as React, which kind of really embrace this functional paradigm. So I would like to kind of review what are some of my favorite concepts in functional programming with regard to JavaScript, and then kind of review some of those techniques, and then also kind of look at some of the coding samples. I will also kind of preface by saying that I am not working at Scandy anymore. I'm working at Revelry now, but we likewise try to embrace a lot of functional programming and taking that as our prescribed method of doing things. So, in summary, I'm hoping what we can review will be these concepts known as partial function application, currying, and function composition. These are three, I think, very popular concepts in functional programming, and I want to see how we can actually leverage them in JavaScript. They are often some of these are actually kind of native to other languages, they're kind of a feature. For instance, currying is a very popular, or it's really embraced by Haskell, for instance. It doesn't necessarily have that same sort of native, doesn't have a lot of the native abilities built into JavaScript, but we can make JavaScript accommodate currying. So largely, we want to ask kind of first and foremost, why would we want to do things functionally, right? Why do this over something that, why do this over object-oriented programming or imperative programming or any other number of different paradigms? And I think in particular, the reason that we're seeing this kind of large increase in popularity is that functional programming, I think, emphasizes fewer lines of code. I think we can all hopefully appreciate that. More lines of code usually means more bugs, if not also more technical debt. I think also as developers, we aim for code that is dry and not so wet. I think that functional programming can kind of really emphasize that. I think also fewer side effects. This is a major deal. We don't so much want to mutate data except when necessary, right? Because I think likewise fewer side effects tends to lead to fewer bugs. And I think it also makes code that is easier to reason about. This to me I think is also very important. We want code that you can, just by kind of looking at it, understanding what it's doing. And this is also, or this is often, I think, manifest in what's known as referential transparency. feel like some of you know what that is, and namely it just means that, for any given input, we can always anticipate the same output, right? So I will also say that this is not always necessarily the case. Just because you do function, you can still program really badly, functionally. But I think that we try to embrace these things and really, do well when we can. And I guess lastly, and this kind of echoes my earlier point about code that is dry, which for anyone who may not know that acronym, means like don't repeat yourself, versus code that is wet, which is an acronym for write everything twice. So when you have a bunch of code that if you're like writing everything twice, it's like super redundant and you have to change things in multiple places when you decide to refactor, etc. But instead, we want code that kind of has like a single source of truth like throughout our code base. And then I would also say that we want code that's reusable, single source of truth, but also that kind of lends itself to like reuse. I mean, there's certain code that just necessarily doesn't lend itself to like use beyond. It's like so tightly coupled to like its context that you can't really put it anywhere else. But we want things that can kind of like dynamically be imported and then reused. But we also want it to be composable so that we can actually use functions to compose other functions. Okay, so first major topic that I'd like to discuss, partial application. So how many people here know what partial application is? Okay, quite a few of you. So for those who don't, in computer science, partial application, I kind of like this definition, is or partial function application refers to the process of fixing a number of arguments to a function and producing another function of a smaller arity. So, like, what does that mean, right? It's like, I don't know what that means. Means that we want to take a function that could have, n number of arguments, but then we want to, instead of taking, like, let's say 3 arguments, we could pass it like the first argument, fix that first argument, or kind of like preload it with that first argument, which will then give us a function that we can then subsequently pass like the following 2 arguments and in whatever like case might warrant. I've also seen partial application. So I feel like Eric Elliott does a really good job of kind of explaining like partial application as it might relate to JavaScript. He says that it's a process of applying a function to some of its arguments, whereupon we might take that partially applied function to return for later use. So if only to put this one more way, a partially applied function is one that it's a function that will take a function with multiple parameters and then return a function with fewer parameters. So let's work with an example here, right? Because that'll maybe help to clarify things. All right, so here we've got a very general add function. Simply take the sum of 2 numbers, takes a total of 2 arguments, right? So A and B, and then it will return the sum of A and B. However, we can rewrite this function in a way that's more like a function generator. So I'll call this generator makeSum, and it likewise will take an argument of A, and at some point also an argument of B, and it will eventually return the summation of those 2. But there's a distinct difference. So the difference is that rather than taking both arguments at once, we're going to curry this function so that it has a fixed arity of 1. It'll be unary in nature, so that each of these functions subsequently takes only a single argument and then returns a function until we finally evaluate our final result. So we can take what would be, we can define a new function, which we'll call add1, and we'll invoke make sum. We'll pass it only one argument rather than our total of 2. And in doing so, we'll actually return a function that takes only like our second of arguments and then returns a summation of those 2. And so we can reuse this like later. We can, for instance, if we want to add 2 to 1, we quite easily get 3. If we want to add 3, we can quite easily return a value of 4. This allows us to kind of preload our initial function in a way that, you know, can kind of, it enables its reuse like in other places and in a way that we don't have to specify that argument again. Partial function application is largely, or it's very often defined alongside its counterpart, currying. And so currying actually, so it has nothing to do with like the food. It has everything to do with kind of its originator, this gentleman named Haskell Curry, kind of appropriately named. So I don't know where you get a last name like Curry. I don't know how you, clearly the guy is really awesome because, you know, I don't know what you have to do in life, you know, to have like your, you know, first name be synonymous with like a functional programming language, and then to have your last name like synonymous or like equivalent with a concept like in functional programming. So if you don't know anything else, like he had to have been a pretty awesome guy. So in currying, again, it's similar, but they're not quite the same. In mathematics and computer science, currying is the technique of translating the evaluation of a function that takes multiple arguments, or a tuple of arguments, into evaluating a sequence of functions, yet each with a single argument, which would be use of partial application. So to try and make greater sense of the relationship between the two, we can say that when compared with partial application, currying would be a function that takes a function with multiple arguments, or I'm sorry, multiple parameters as its input, and then returns a function or kind of a sequence of functions all with exactly one parameter or one argument. Again, we'll kind of lean on a very arbitrary example. All right, so consider that we have a logging function, and it takes a total of 3 arguments, right? So the name of our function is log, takes 3 arguments. So first argument is status, which will be like, you know, info, warning, error, context. So that could be like, you know, a database context, API context, any number of different contexts that we want to pass, and then a message. So that'll actually be the message that'll be contained by our error. And what we want to do is we want to rewrite this function in such a way that it is curried. So kind of currying is both a concept, but it's like something that we can also do to a function, right? So we can take a function that ordinarily would have like 3 arguments that are taken all at once, and if we curry it, we can return a sequence of functions that are all of a unary nature. And so when you curry a function, like all kinds of things could potentially happen, but in a most basic sense, you can kind of think of a curried function as one assuming this shape, right? So we've taken that log function, and it now equals a function that returns a function that returns a function. This is our sequence. I don't know if everyone can kind of see that. And so I'll kind of ignore the fancy logging code. All right, and then for anyone who maybe is like older school or like not as used to ES6 like syntax, this might look a little more familiar. So essentially in JavaScript, you're just, taking a function that returns a function that returns a function, and each of those all take a single argument. Same as this one, no difference. And then in terms of usage, we'll take this log function, and we can call it, we can kind of consume it all at once. And to do so, we'll pass it all 3 arguments. But rather than pass it 3 arguments in one function call, we're going to invoke each of the subsequent functions that comprise that curried function, right? So we have kind of other level, which would be the status, and then some context, which would be the context, and then finally a message. I guess if I can kind of draw your attention to this first usage here, perhaps if you're not used to seeing this, just want to take a moment to think okay, so the syntax looks a little funny, right? And what exactly is going on here? I mean, how often do people usually see this? Is anyone used to seeing that sort of thing? Might look kind of strange. It's kind of strange. You don't see it too often, but there it is. And the reason that it looks kind of funny is because we have the sequence of parentheses that are kind of invoking what looks like we see a sequence of parentheses and what is actually happening there. So what's going on? So essentially, because we have a sequence of functions that are returning functions, we have to invoke each of those in order to evaluate what will actually be a result that's not just another function, right? And so only by invoking it a total of 3 times will we arrive at our result. So it looks a little funny, but I'm hoping that we can start to see how this could ultimately be useful. Although I will, and I'll return to this, but there are kind of helper functions, curry helper functions that allow you to specify any number of arguments that you might want to at any given time. So you could, if you wanted to avoid this strange syntax, actually pass it all 3, and it would still understand what you're trying to achieve. But returning then, in this case, let's say that we want to take our very generic logging function, and we want to create a more specific variation of that logging function. So if we want to use the logging function, but we want it to specifically use a status of info rather than error or rather than warning, we can preload that curried function with our first argument, info, and that'll just kind of stay there. That'll just be a sequence of unapplied functions that we can then reuse at any given time. My general rule with curried, or with when is it a good time to curry a function, is if you find yourself calling a function that takes multiple arguments, and if you find yourself calling that function over and over, and if you find yourself also passing it a lot of the same arguments over and over, it's probably a good time to curry that function or to partially apply that function, because then you can reuse it and you don't have to keep specifying these same arguments time and again. In this case, we can then take our new info function, which simply preloads that log function with a status of info, and then we can pass it our subsequent arguments, and then that'll evaluate, that'll then execute that fancy logging code that we saw earlier. Likewise, we can iterate further on the info function. So if we've applied, for instance, info, but we also want to fix what could be the database context, we can do so by taking info, applying a context of DB, defining that as a new function, database info or DB info, and then finally pass that what would be the last of our arguments, namely the message that we want to pass. Any questions on that? I feel okay. Oops. Okay, so what that means is that by way of, okay, that's how we would manually curry a function. We would have to kind of tear it apart, break up its arguments in such a way that we can pass it like one at a time. But if we had kind of a curry function, so a function that could take any function that you have with n number of arguments and then translate it or convert it to that same function, but where it's now curried, that could be like something that's potentially useful, right? Then we don't have to do all of that like by hand every time. We can kind of automate the procedure. We can sometimes even avoid the strange syntax of like A, B, C, where each one is a subsequent function call. And, you know, then pass it like 2 arguments at a time, 1 argument at a time, all 3, doesn't really matter. So for our example here, we'll just pretend that I have a function available at my disposal called curry. And it will take status context. It'll essentially just take, we can curry like the our ordinary function, put our like logic there, and then we can use it with like all of the arguments at once. We can, as we did before, likewise create an info function where we can, you know, pass it like just the remaining 2 arguments. We can also create another third function called API info, where we specify the context, and then we can even later use that to pass it only the message portion. And then finally, if we want to, we can specify, you know, only 2 arguments at a time, namely by passing in like warn or warning for our status, and then DB context for our context. And then finally, if we want to reuse it later, we can pass it simply the message itself, which would be DB warn. We know that. Sorry, I think there's a difference between my screen and this one, but this would be DB warn. All right, so maybe wondering, like, why would any of this like be necessary? And I think that if partial application and currying are sort of like the topics, the theme to this talk would be function composition. Function composition is kind of like, I don't know, that's something that I feel like we should all sort of like strive, something we should all strive to do, like, you know, more of like as often as we can. And what that would be is that it would, function composition like enables us to easily connect what would be a number of functions together in such a way that we can build more complex functions. So we can kind of define things in a bunch of smaller pieces that we can then compose together to orchestrate our intended result. In practice, in JavaScript, you see function composition take like a few different forms. I would say that the most common form is when you have like a function that's called and then which would be passed as like an argument to another function, which could then evaluate and then pass to another function as like, you know, that given argument. The idea then being that if you can take the return value of one function, you can then feed it as an argument to the outside or enveloping function. And in our case, since the function can only return one value because it's unary, unary being that it has an arity of 1 or that it has only an argument of 1, the applied function, we can kind of, you know, reasonably sort of like envelop like one by another. So rather than lean on such arbitrary examples, I was hoping to kind of delve into maybe something a little bit more practical, but also hoping not to get too complex because kind of in preparing for this presentation, it just occurred to me as to how difficult it is to read code and kind of how much focus like it takes, and how even sometimes like relatively simple examples can be difficult to grok like per se when if there's only like a few moments to do so. I'm hoping that this example will strike a nice balance. All right. So for this case, what I want to do is take what is a pretty common thing in JavaScript, namely the switch statement, and I want to see if we can't develop a more functional alternative. See if we can't develop a functional alternative to the very imperative switch statement. So, although very useful, and I'm sure maybe there's a lot of people who would really hate me if I were trying to tell them that I wanted to redo like the switch statement. I do have to say that traditionally the way that they are used in JavaScript, they're not usually immutable. They're often not immutable, and they don't really lend themselves to composability, not in any inherent way. So what I'm hoping, I can kind of say that I think switch statements are notorious for kind of leaning on use of side effects that can be harmful. They also often require use of break, which I think is both kind of confusing, and it can lead to some pretty gnarly bugs if you forget to kind of break each of your cases. My question then is, can we develop a functional alternative to our switch statement, and namely one that we can think of as pure, as immutable, and also as composable? So how many people have seen something like this before? Yeah, quite a few of us. So you take, you have this, I can kind of walk through this. We have this, this variable day, and we're going to use this variable like in this switch statement. So we're going to define a switch. For anyone who doesn't know what a switch statement is, it's kind of like what it sounds like, right? So you think of like maybe an old, I think of like an old switchboard or something to that effect, where we're going to go through a bunch of different cases, and for the first of those cases that match the expression that we've passed it, we're going to return that given result. We're going to at least like execute the code that would be encompassed by that case. So in this case, we'll have, we're going to try to get the current day, and depending upon the result of that switch expression, we're going to iterate through each of the cases. And then so if you don't know, like date, like the get day method on the date object in JavaScript will give you a number that corresponds to the given day of the week that it is. And so in this case, we want to take that number and then like attribute a string value to that number. So we take 0 through 6, and depending upon the value, we will then reassign a new value to day, which will then, we can then like use or consume at another point in our application. And for each of these, we have to break. You don't have to break if you return out of each case, but you do if you don't return, and this can get tricky if you forget. What I'm hoping then is to leverage functional programming in JavaScript in such a way that we can build a functional variant on our traditional case, our traditional switch statement. And so what we'll do is we'll define a new function. We'll call it switch case. This function will take instead an object, and that object will essentially have a bunch of key value pairs. And each of the keys in that object would correspond to the kind of string or number that would be evaluated in a switch statement. And then the value for each of those keys would be the value that we would want to return from our switch statement. We'll also allow for a we'll allow for a default case that will comprise kind of our second argument. And this would be, I guess, like in a switch statement, you can, you could try to write it in such a way that if you don't have, if nothing matches up, then you can return another value in all other cases, and we'll likewise want to do that. And then finally, we'll need to pass it a key argument in order that we can actually apply our switch case function to a given key so as to return our intended result. So just to kind of like dissect this function here, what we'll do is we'll look at the key. In this case, it'll be a number or a string. We'll want to check whether that key exists in the object that we're passing it. And if that key does exist in the option that we're passing it, we'll return the corresponding value in the object that we've passed it. And then in all other cases, we'll return the default case. Does everyone kind of see that? Okay. I'm also going to include two other sort of like helper functions. We'll have kind of an execute if function that simply looks at any given argument that you pass it. It sees whether or not JavaScript would consider that a function, and then in the event that it does, it'll execute it, and then in all other cases, it'll just pass it along. And then finally, we'll have like a switch case function, which will be just like our switch case, our own like switch case function, except that you can pass it an object where all of the values in that object are a function. And in the event that, you can then like execute it in the event that that's something that you would want to return. So if you want to actually return, if what it is that you want to return is the evaluation of another function, you can do that. Or like the call to another function, you can do that. Otherwise, we can always lean on our typical switch case. So for anyone here who's worked like in Redux, you've probably seen this before. Who's worked in Redux? Okay. Who's seen this example before? Okay, quite a few. Okay, yeah, so this is like, I think, straight from Redux docs. And what they're looking to do is to, based on the action that you pass it, we're either going to increment our some variable on our state, or we'll decrement some variable on our state, and then in all other cases we'll simply return our state. In this case, increment or decrement would be the action type that we've passed it. But we'll see that rather than using this sort of traditional switch statement, we can use ours, which is not only it's fewer lines, but I also I find it a little bit easier to read. Maybe you don't. So instead, we pass it the state, we pass it the action, and then we return our switch case function. So essentially, if you can see, the switch case function is operating on an object, and in that object, we have our two keys, which are increment and decrement. And then the values for each of those keys would be functions that return whatever the state variable is that we've passed it, incremented or decremented by 1. That will operate on the state that we pass it, which would presumably just be whatever that might be. And then the action type, which would correspond to the increment or decrement keys. this also kind of makes it a lot easier to, add new handling, like for, our switch statement. So rather than having to write out like a new case and all of like the code that would take, we can simply add a new key value pair to our object. So if, for instance, we want to reset the state, which would be a number, to 0, we simply specify a new key of reset, and then we can pass it 0. So this is like really what I mean when I say that, when we use like functional programming the right way, we can kind of like cut down on lines of code, and then also, I don't know. There's like one other thing that I guess I would want to like mention here is that we are kind of using data in such a way that it operates as code. And I feel like this is also a very important concept. So rather than having to specify new code, we've simply had to add some new data in such a way that we can programmatically do things. I think, I feel like, functional programming has been very good at, not keeping those so distinct. And that part of its latent power is its ability to often treat data as code. Okay, we can try another example. Returning then to this switch statement where we're trying to kind of take days of the week. We try to get the current get day, which will be a number, and then based on that number, we'll try to set the variable. But using our new like switch case function, you can see the alternative, right? So instead, we simply need specify an object where each of the keys would be a number, and then the value would be the day of the week that we mean to return. And we're also kind of using the second argument there, which this is like the default value. So unknown would be like if we pass it a number that's not encompassed by any of the keys in this object, we can always like default on a value of unknown. And just for when I do return to it, get day will be the name of our function. And I mean, so can anyone see sort of like does anyone see, I guess, like how we've used currying and partial application here? I mean, because we have our switch case statement, which, returns a sequence of functions for which like the, I guess, like kind of total argument order would be like 3. And we have partially applied it in such a way that we've passed it the first 2 arguments. And so now this function is completely preloaded with those arguments in such a way that we can then pass it what would be the 3rd argument. And that'll finally evaluate to a result that's not actually a function. It'll kind of just give us a more traditional value. So we know that the alternative is terser. It is fewer lines of code. That's not always necessarily a good thing. I think it's, generally something that's good, maybe not necessarily. I'm saying that, that's not all. And so what I'm saying is that because we curried it, we can kind of decompose our switch case in a way that lends to like reuse and reuse for multiple other methods. So we can do things like get current day, which will use our get day function. We'll pass it a number or whatever the current day is by way of like this JavaScript method, and then we can like finally log it. So again, we've taken like what was a function preloaded with some arguments, and then now we can like simply call it, and it'll give us like what we need. I think I also would like that we can use our switch case function in a way that's programmatic. So this is where things start to get really fun, I feel. We can, for instance, take what would be a list of days, and then like we can take like a list of days, and then we can kind of like work on them in such a way that we then pass them into our switch case statement. That's something that we really probably, I'm not even sure you could really do that in a way that like wouldn't, I don't know, be really hard to do with a traditional switch statement, but we can totally do it with our switch case function that we've developed. So in this kind of example, we've got the days of the week. We'll start with like Sunday in through Saturday. And we're going to pass it into our switch case function. We're going to pass a function that operates on these lists of days that will then be consumed by our switch case function. And I guess we can try and break this down here, right? So we've got the days we're going to reduce on these days. So for anyone who might not know what reduce is, reduce allows us to take a collection of items and then sort of, I like to think of like reduce as like all to one, like that's sort of the relationship. That's not always like the most accurate way of explaining it, but it doesn't always like try, like you can kind of reduce on anything, right? But that's, I think, the most common way to sort of think about it. But we can take a collection, and for every item in that collection sort of arrive at an accumulated total. And so in this case, what we want to do is we want to take our list and then from that list create an object where where essentially a number corresponds with our day of the week. So 0 starting with Sunday, and then leading all the way up to Saturday. And so this function will take our list of days and then accumulate them in such a way that they then are an object, where it would be like 0 would be equivalent with. We're essentially creating the object that you see here, but by way of a reduce. We'll create that object and then kind of pass it into our switch case statement kind of for later use. And we've managed to do that without having to, we haven't even had to define every part of that object like as like its own thing. Instead, we've been able to like programmatically accumulate that object then for like later consumption by our own function. Likewise, we can sort of print the day. This isn't really all that different. It's kind of the same example as before, but we can essentially say that like, the day is our given value, and then likewise kind of pass it in as, we can pass in like an alternative like version. And all I'm kind of really getting at with this example is that our code is highly reusable. It's not even so tightly coupled like to one implementation or another. It's really something that we can like use throughout our code base. And then from there, I guess segue. Are we on time? A little more time, or? Okay. All right, so this is a more in-depth example. We'll see how far we get with this. But this is an example from, This is an example from like a coding kind of interview that I had, where I was asked to create a histogram like from some like vehicular data. So essentially they gave me people interviewing me gave me like this list of like these massive hunks of like JSON, and they asked me like, okay, we want you to create like a representation of a histogram from this data, and this is kind of like what it looked like, right? So we've got these just massive objects, and this is all information relating to, a given vehicle. And what they wanted me to do was to create a histogram based on the city fuel efficiency. So for this given car, that's a value of 19, you get 19 miles on the gallon. And then highway fuel efficiency. So for this car, it would be 27 miles on the gallon. And the same for here too. So what they asked for me to do then is they wanted me to kind of abstract the city fuel efficiency for this huge collection of cars in such a way that I could kind of represent the ranges by way of the key over here, and then give the total count of cars in that collection that fell within range. So if for anyone who doesn't know what a histogram is, or if you forgot like I did, histogram is just it's just a way of representing ranges of data. So if you've got, let's say 3 of this thing over here, how many out of the total collection would that amount up to, or that sum up to? We want to do kind of something. We're not going to create a graphical representation, but we can do so by way of our object here. So for our collection of all our vehicles, we want to say okay, for all those that have a city fuel efficiency that falls within 15 to 19, give me the total count. For all those within 20 to 24, give me the total count. Likewise, 20 to 25 to 29. I think you get the idea. The idea though is that we can get a total count based on the ranges that would span all of those objects. So this isn't this is kind of it's not the most straightforward operation. There's quite a few things that we have to do here, right? So we need to both define all of the kind of different bins, as they're called. So with regard to histograms, you've got bins, which kind of represent the ranges that we've illustrated here on the left. And then we'll have the actual counts, which will be represented as values on the right. The reason, so in addition to getting city fuel efficiency, I was also asked to, determine the highway fuel efficiency. The reason I kind of say this is because by way of using functional programming and kind of creating very reusable functions, you'll find that if you do things right, you can very easily calculate either of those by changing a single argument. So this is my implementation. This is pretty lengthy. We'll see how much time we have left to kind of we'll just sort of touch upon it. But I think to actually break down the entire problem, we would exceed time. So I think I started by just creating some very generic kind of helper functions. I often start like this. So we have a very basic sum function here, which you might have remember from earlier. We take 2 numbers, we return 2, and then I'll have a very basic incrementer function where we pass it a number and then return the sum of that value, but incremented by 1. Maybe we'll just touch on this first function here. So the first thing that I felt like I needed to do was I wanted a way to programmatically create those bins that I mentioned that are represented here, right? So we want a way that we can create an array of numerical pairs, and where each of those pairs abides by a certain width, right? So the width in this case would be, I guess, 5. I mean, so if you count 0, so 0 to 4, that's a total of 5. And what we'll want to do is we'll want to kind of construct these bins, right? So in this case, we'll want to specify, first of all, the minimum number, which in most cases will be 0, but who knows, maybe you want to start it at 100. We'll want the maximum number, which will be, we're just, defining the range that we want our bins to, conform to. So We could say 0 to 100, and then we'll want the width, which is that number that we'll use to calculate the range for each of our bins. So before we had, 0 through 100, we'll say, and the width was 5. And then I'm also going to specify an initial value for the accumulator. That doesn't make sense just yet, but once we get into it, it'll make a little more sense. And the reason is that this will actually be a recursive function, because we will want to sort of like operate on our, we're gonna essentially reduce on the return value until it is like where we want it to be. So the first thing that we'll sort of do is we'll ensure that we have not exceeded our max value that we've passed it. If it like is equal, or if it is greater, we'll simply return our accumulator value. And again, that accumulator value will start out as just an empty list. And then in all other cases, we're going to recursively call on our function by referencing it as like make bins. And essentially we'll increment the minimum, just so there's no overlap. We'll pass it the maximum, which will remain constant. We'll give it the width, and then where the kind of real crux of the function, that will reside here. And essentially what we're going to do is we're going to take our accumulator, which is an empty list, and we're going to concat it with this range that we've calculated. And by kind of recursively calling like on our accumulator, we can eventually return a nice value that'll be an array of numerical pairs. I think that's probably good for this. I could go into the rest, but it starts getting kind of hairy. The only thing that I might kind of wrap up as a closing comment is there are a ton of libraries out there for JavaScript, functional JavaScript. I think, for any of you who write in this language, I'm pretty sure that a very, very common one is Lodash. There is a functional programming variation of Lodash that kind of auto-curries all of the functions so that, we can use it in a way that we kind of were showing earlier. It's essentially the same installation, but it just gives you a few other helpers and auto-curries things, so that's nice. There's also another library called Ramda, which is it has a lot of the same functions that Lodash does, but it likewise kind of auto-curries everything, but it offers some other methods that are pretty helpful and that like Lodash functional programming doesn't have. The other thing that it does that I think is kind of nice is that it treats it kind of evaluates the value of things rather than what the reference of something might be. So if only to kind of clarify that, JavaScript typically when it's referencing, if you say like A is something, it's actually looking at the reference for whatever it is that you've pointed to. It's not necessarily looking at the values. Ramda is useful because it always kind of evaluates the value of something rather than what it is that it might reference. This becomes really important if you're trying to work with data in such a way that you're trying to treat it as immutable. So I don't know. I like Ramda. It can sometimes be slow if you do really expensive operations, but it's otherwise fun. And here's some further reading. Eric Elliott's always good when it comes to functional JavaScript, and there's some other online books that are really helpful. And that's basically it.
So we have a few minutes for questions. You can come to the mic and ask your question here so we get it on recording. Anybody?
What was that weird syntax or that weird return type you were using in the reduce function for when you.
The comma value.
Mhm.
Yeah. So for everyone. Okay, this is what you're referring to? Okay, so this is actually probably not the way I would do this now, but so I'm sorry, your name? Nate. So Nathan's asking about this kind of weird return value that we have here, and this is a little odd, but essentially what we want to do is we want to modify our object and then return that modified version. And the way that I've managed to achieve this is by, all right, so in JavaScript, this is actually kind of weird, but if you return like two expressions that are like separated by a comma, it will actually evaluate the first result, but then pass you only the second result. So in this case, we have modified our object in such a way that we've given it an index, we've assigned a value to that index. This is operating on the accumulator object, and then we're simply giving it that accumulated object after the comma. So that's what that is. If I were doing it, if I probably wouldn't do that again. I would probably try to use like the rest operator to simply modify the accumulator in such a way that we're not actually mutating it. The reason I don't really like this is because we're technically mutating the object and then returning it. It's not so bad because it's being done like programmatically, but I don't know, like I'm always striving for purity.
Yeah, have you, well, two questions. Have you ever read the book JavaScript Allonge or seen it?
I'm sorry, LNJ?
Allonge is Allonge. It's a book teaching JavaScript in a functional way. It's pretty good. And the second question is, have you ever, since you're into functional programming, have you ever seen JavaScript? JavaScript. PureScript?
I've seen PureScript, haven't used it though. I would definitely, I don't know, I'd like to almost like refresh on that. It's like one of those things I feel like I've read about and would like to learn more.
You said you're working at Revelry right now. Do you get to use functional JavaScript stuff there? And it's encouraged, you said?
Totally encouraged. I feel like, we use React like a lot, so I feel like any team is really embracing React. It's like, they're trying to drink the Kool-Aid, trying to come to Jesus, however you want to put that. So yes, we totally do. I think, I wouldn't say that we embrace it so much that we like try to proactively avoid like object-oriented programming, but I feel like the general trend in most of the code reviews that I do is to mostly embrace it. People probably think that I'm being like too pedantic when I make certain comments and such, but I think yeah, we definitely do. I probably take it for granted, maybe there are like a lot of other businesses that aren't like embracing this in full yet, but I really wouldn't want to do it any other way. Anytime I see stuff that's like really too imperative or trying to, work with like prototyping or like the prototype model in JavaScript, it's just way harder to follow. Anytime I see this, like a little part of me inside screams. Thank you.
All right, let's get